Okay, so today we're doing inverse trig functions. So normally when we look at a trig function, we're given some trig function is equal to some number k, right?
Yeah.
That's how we normally see them.
Probably.
Inverse trig functions then go the opposite way, and that instead of solving for some ratio k, they solve for the angle theta. So if I had the same situation, that means that the inverse of sine of my ratio k would give me my angle theta. I know it sounds really confusing. We're going to write them out formally, and then I'll show you exactly what I mean. Same thing applies for cosine. If cosine of some angle was equal to k, then cosine inverse of k would give me my angle.
Oh.
And you actually have a cosine and sine and tangent inverse button on your calculator. Or it might say arc sine or arc cosine or arc tangent. They mean the same thing. So this also applies, of course, for our tangent theta. We would use tangent inverse then of whatever our ratio is, and that would give us our angle theta. The next three are where it gets different because I don't have a secant button or a cosecant button or a cotangent button on my calculator. So we have to get a little creative. So if I was given cosecant of some angle theta and it was equal to some ratio k, then to find the inverse, I would use the inverse for the reciprocal of cosecant. So what trig function is the reciprocal of cosecant?
So it's 1 over.
It's
cosine.
sine.
Yeah.
Yeah.
So we would use sine inverse of 1 over our ratio k, and that would give us our angle theta.
Are these all like the inverse trig functions?
These are all three or all 6 are inverse trig functions, yes. And this is how they get plugged into the calculator, which is why I want to write them. So-
Basically our equation.
They're our ratios just different. Yeah, just backwards. So if I have secant of some angle theta and that were equal to some ratio k, then I would use cosine inverse
Cosine.
of 1 over k, and that would give me my angle theta. Same thing then for cotangent, because we don't have a cotangent button, so we use its reciprocal tangent, and then of 1 over whatever our ratio is, and that would give us our angle theta.
And that's our notes.
This is our notes. Now we're just going to practice it.
Oh.
Oh,
it's pretty
hard.
This is all the rule that we have to know. That's it.
Wait 1 second. I just want to
Thanks,
right now.
Miss Doreen.
I'll give you guys a second to make sure this is written. This is definitely something you should have on a cheat sheet for a quiz or a test. It's very, very helpful.
I actually learned how to copy and paste your notes onto it.
How's that?
Like you literally
Just cut it out and put it on there.
Yeah, just get some of that scissors and that glue.
Just make a scrapbook of a cheat sheet.
There you go.
Is that 1 over K?
That is 1 over k, yes.
no,
Have you ever had a kid?
No, that's twice.
Notes on what it's.
The difference is I'm actually fat.
I'm fat.
Hey, you're not fat. Shut up.
Look at that.
I'm fat with a CH.
I know, no. If I had a liposuction, you know how much would come
I'm
out
so
of
glad
it?
this conversation is being recorded.
Oh, shoot.
Do you have to restart it now?
I'm not restarting it.
Sorry, everybody
I
on
listened-
YouTube.
I listened to your
Hear
guys'
me talk about how
conversation.
fat I am.
All the time in the videos, right?
Like and subscribe.
Like and
Don't
subscribe,
forget the
thank you.
subscribe button.
Welcome to
Leave a
my
comment below.
outfitted YouTube page.
The first thing you
Leave a
hear when
comment
the video
below on
starts
if you think
is,
I'm actually
Jerry.
fat.
You should post it.
Welcome to adulthood about learning trigonometry and listening to pubescent kids talking
Me,
about
Jerry,
themselves.
and Chandler.
Okay, so let's start with some triangular examples. So let's say I have a right triangle. On this right triangle, I have some angle theta, and I know that my side lengths are 3, 4, and 5. And I would like to solve for angle theta here. That's my goal. So first thing I need to do is I need to pick a trig function that deals with the sides that I have been given. So here I have all three sides, which means I can pick any trig function that I want to. I don't have to pick sine, cosine, or tangent necessarily because I can pick any of them. So which trig function would you guys like to use?
I'd say.
I heard cosine.
I heard secant.
Oh, I like secant better. Let's do that one.
I heard, let's go home.
Okay, so given that this is my angle theta, and we're doing secant of theta, I have to know what secant is equal to.
Okay.
So secant is what over what?
Oh, let me go write this.
Hypotenuse over adjacent.
Hypotenuse over adjacent. Good.
No, because it's the opposite
Of cosine, yeah. So what's my hypotenuse length here, Jonah? 5. And what's my adjacent length here? Anybody? 4.
3,
2,
1.
1.
You guys are so funny. So now, since I have the trig function I'm using and I have what it's equal to, I can use my inverses. So we already know that we're not going to use secant inverse because it doesn't exist. I'm going to use cosine inverse of 1 over that ratio
So why are you using cosine?
because it is the reciprocal to secant. Okay, my ratio was 5 over 4, so I need to do 1 over 5 over 4. I don't know about you, but I hate the way that looks. So what do I know I can do with a fraction in my denominator?
You can like put it to a decimal.
We can flip it over and it becomes part of our numerator. So this is the same as cosine inverse of 4 over 5.
Well, listen to that.
And then I can just plug it into my calculator. I'm looking for a degree angle, so I need to be in degree mode on my calculator. And I type it in exactly like this, and it's going to tell me what my theta is equal to.
Wait, but that just made the one that not includes
The 1 was on the top, so it meant everything. But then 1 times 4/5 is 4/5, huh?
36.87.
So wait, you timed the top 5?
No, it's 36.869.
I flipped the bottom and multiplied it into the top.
I think we
Now.
rounded.
Okay.
So it might be like
Okay, so what did we get decimal wise?
36.869.
Okay, so 36.9, which I'm going to go ahead and round up to approximately 37 degrees.
Oh, you want us?
You will follow whatever instructions the homework has. So if it says round to 2 decimal places, you round to 2 decimal places. If it doesn't,
Confused we got.
rounding to the nearest whole number is fine.
Whatever, right?
No, it's in degree mode.
We have, Jerry, we have reciprocal identities. Sine and cosecant are reciprocal. So sine is equal to 1 over cosecant. Cosecant is equal to 1 over sine. Secant and cosine are then reciprocals of each other. Cosine is equal to 1 over secant. Secant is equal to 1 over cosine. And then cotangent and tangent are reciprocals. So cotangent is 1 over tangent. Tangent is 1 over cotangent. We wrote those down a while ago.
You understand?
I got 0.9.
Are you in degree mode or are you in radian mode?
Degrees.
Are you sure?
This is D.
Did you use it in
So like if we were using tangent, the reciprocal would be.
What are we supposed to
Cotangent.
Are we supposed to use the inverse?
You should be in degree mode.
Cosine?
I'm gonna, did you use cosine or did you use cosine inverse?
Wait, which was the first?
You should hit second and then cosine.
Second.
It should show
Why
the
would it
cosine
matter?
inverse.
Hold on, doesn't matter.
If that matters.
You got it?
Yeah.
So it is cosine inverse, not cosine. If you didn't already see, the inverses are like printed above your sine, cosine, and tangent buttons, and you have to hit second and then whatever trig function we want to use. Are we all okay with this? Let's do another one.
What's the hardest one?
They really aren't. I don't know. Easy breezy.
Let's do
So
it on
let's
our
say,
own.
oh, I don't know.
We do it on our own.
In a second, yeah.
No, this all took me the homework, you're gonna have another choice to it.
No, this is really it. We're just gonna represent it in different ways.
This is gonna be using the
So
same.
basically, we have solved.
Can we use tangent?
Why would we use tangent here, Kennedy?
Because it's
Because
TOA, which is opposite over
So she acknowledged that the two sides I was given were my opposite side and my adjacent side, which means I could either use tangent or I could use cotangent. Tangent's the easier one because it actually exists on my calculator. So she recognized and wrote down what our trig function was. And now she can go ahead and do the inverse. So it becomes tan inverse of 12 over 9. And that's going to give me my angle theta. Take it to one decimal place on this one.
Nobody announced it yet.
Did Jerry just say smart girl?
He did.
Is he trying to flirt with Mary?
Jerry, what are you doing? Jerry,
Come on, Jerry, you have a girlfriend.
I do actually.
It's me.
Oh.
Landon, what'd you get?
I got it.
Anybody else get 53.1?
I originally got a syntax here, so I have to put 9 and then a parentheses.
How do we feel about this?
I'm confident.
We're going to do-
More.
One more, and then we're done. Cool.
Oh my gosh, you're gonna give us one, and it's gonna be the hypotenuse because that's the only way you can find the other two.
Actually, no, even with the hypotenuse, you couldn't find the other two unless you had more information.
Yeah.
No, yeah. If you only
Are
have
you
one side, you
this
can't
way
do it,
right
right?
now?
If you only have one side and no angles, we can't do it,
Stop
correct?
falling in the air.
Okay.
I don't know what that was.
I'll wind it up.
That's what.
It's like you're bowling.
Alright.
Okay, so we might need a little bit of help with this one.
So this time, I've given you the trig function, and I've told you what it's equal to. And I would like to find the angle x. It works the exact same way. Do I have a cosecant inverse on my calculator? So I need to use its reciprocal inverse, which is,
Sine,
Sign.
inverse of sine 1 over k.
so sine inverse of 1 over negative 0.5. And I can just plug that into my calculator.
Well, in this case,
Yeah.
Dude,
Nobody announced it.
I'm gonna announce it, Kennedy.
I'm gonna punch you.
I'm gonna
Keep
announce it.
trying to put the in parentheses, like in the fraction.
2.
Oh, wait, you gotta do that.
Got an error.
It says domain error.
Because you guys put the negative with the 0.5. Yeah, well,
Would it work
I
otherwise?
got
No, it
This
doesn't.
don't work.
bands.
This
Did you
is
get-
unsolvable.
Why is it?
Yeah, because it's a domain error, so it's unsolvable.
So can I just write domain?
Solve.
That's
All
all.
real number.
You crack me up. This one is not solvable.
I could've
So
told
what
you that.
if I changed my function to be sine of x now?
Same thing.
Could I still solve it?
No.
Try it.
You want me to tell you
Oh,
real
it's
quick?
the inverse.
Yes,
Try
you
it.
can.
What inverse would I use?
You in negative?
I would use sine inverse of negative 0.5,
Oh wait,
Oh,
no.
you switched this.
and I get my angle.
Negative 30.
Yeah, negative
That guy
30.
said. But you
Okay.
have a negative.
You can have a negative angle, that's 100% okay. However, there are limitations to using your calculator for inverse, because negative 30 or 330 degrees is not the only angle where my sine is equal to negative 1/2.
You gotta add.
So you got negative 30 degrees. I agree with that. To find its coterminal angle that's positive, we would add 360, I'd get 330. But there's actually another angle where that also happens, and that is our 210 degree angle. So when we use a calculator, it's only going to give us one of our angles. There are possibly more. So I always suggest that if it's something like this where it comes out to a nice whole number angle, and this angle exists on our unit circle, we should check our unit circle to see if there's more. Because it would be negative 30, which is equivalent to 330 degrees, and it would be 210 degrees.
Where did you get to?
I know from my unit
Do we
circle.
have to put that?
If there's more than one, yes.
How do you
So
know?
that only happens if you get an angle that you know is on your unit circle. So if it comes out to be 30, 45, 60, 90, 120, 145, I did that wrong. 90, 120, 135, 150, 180, or any of the ones on the bottom.
Wait,
Okay?
so if this were like Okay, so if we were to get the cosecant of x, would we do that on like the homework?
If you got cosec, like we just did, you said it was undefined.
Would we put undefined, or would you want us to do it with the sign part?
No, it would be undefined. I changed the function entirely. That's why we were able to do it.
Okay, that's what I was.
Yes, Jonah.
So when you went from negative 30 degrees to 330, did you like add?
I just added 360. Yep.
Oh, it's equivalent to.
Yes, those are equivalent to each other because they're coterminal to each other.
So you do put either one? Or do you
Yes,
put all?
either one is fine.
Will there always be two for each one?
There are sometimes there are 4, sometimes there are 2, sometimes there are 1, sometimes there are none.
So you can't always just have one.
We can't just always. Well, you can always add 360 and find a coterminal angle. It might not help you at all though,
And watch with the 210 number.
because it also exists at 210 degrees. That's another place where my sine value is equal to negative 1/2. And you can check it on your unit circle.
Just because it would make it
So-
really complicated.
Basically, if it's a 5 ends in a 5 or a 0, we should do the coterminal thing.
Pretty much. If it ends in a 5 or, for the most part, if it ends in a 5 or a 0, you should definitely check to see if there are other angles that also work. So just know that your calculator does limit the answers that you get, but that's okay for the purposes of today's homework. Okay, so your homework is on Canvas. Obviously, if you have any
Miss
questions, let me
Carl.
know. And then if you don't, then it's due tomorrow.
I
The
don't know how it's
document
on
redo was currently being processed. Please try again.